Right, so we're talking about our third collection type in Python still, and we're on sets, which is the third collection type in Python. We've looked previously at lists and we've looked at tuples, and we're in sets, and we looked earlier in our sets at the creation of sets and what sets are. Now, what we're going to do in this particular section is look at one of the methods to start with, which is the clear method. And the first thing that we're going to do is let's create a set. So let's just see if I've got one here. Just going to do this. In fact, I'll copy all of this and then I'll just modify the code. So we're going to create a set. Our set is apple, orange, and banana. We're going to print our set, and we're going to print the type of the set as well. And in fact, what we'll do is we're not going to print the type because we already know that's of set. So let's just print instead the identity, which is the memory location. We're going to talk about the memory location of sets. So we're going to put it into an F string and identity. And remember, to get the identity, we use this ID method. So ID of S. And if we put an equal sign, this is just something new just to throw in, but inside the curly braces, we can put whatever variable we want. It's quite convenient. So we're going to get the identity of the set. In fact, I'll just print this out at this point. We can see identity, and then obviously we get the identity of the set, which is this unique memory number that's allocated. It returns the identity of the object. It's guaranteed to be unique amongst simultaneously existing objects. It's a unique memory space that this represents. If I just stick an equal sign in there, we get ID of S equals all of that. So it's just a nice extra bit so that we know what variable or what we're actually getting out. So we'll continue from there, and we've created this set, and now we know that it exists in a memory space, and this is where it exists in the memory. It's been allocated this particular number. So, and we can even recall a memory. So mem1, we can call it memory1, and we'll say that's equal to the ID of S, which is exactly this number over here, which we've already printed out. So we've kind of like stuck that into memory. And what we're going to do is we are going to let's clear the set. So we're going to try and use our clear function and see what happens. But the reason why I'm showing this particular function and looking at the memory is I'm going to clear the set in two different ways, or attempt to, and we'll see what happens when we do that. So s dot, and then we can just go, it's our second method over here, s dot clear, clear returns none. We can see that down the bottom here, clear returns none. So s dot clear, it returns nothing back, and we're expecting it to just clear the memory. So what we can do is we can print S, and also actually we can just copy a lot of this here, which is we can print the identity of it, and we can also get the memory location, but instead of the memory location being mem1, we'll just change it to mem2, just like that. So we're going to clear the set. Presumably we will get an empty set, and we're just going to see where the memory location of that set is. We are expecting it to be in the same memory location. So just let's have a look. And that's what we get here. So we've got our set apple, banana, orange. We've got the identity of the set that came from line number 6 over here. So we've printed that out. Then we have cleared our set. And one of the things to note here is that when we print S from our cleared set, we actually get set that comes back. We don't get two empty curly braces. So just something to note on the side. That's what we get back from it. And we haven't done if statements yet, but I'm going to go into it anyway. I'm going to use one for the sake of it, so just take it as a given in a way. But maybe it might be quite obvious as to what I'm doing, but we can check if they're in the same memory location. We can just check. So how do we do this check? We can just do an if mem1 is equal to mem2, noting that we've used a double equals and not a single equals, because a single equals means assigned to the value of, whereas a double equals is a logical equals to. Are they actually equal to each other? And then print same. They got the same identity. So basically, if memory 1 equals memory 2, which we see here, then we might have missed a number somewhere, then this print statement, then this if statement will be true, and it will jump into its little block of code and run it. We've got one line and we're going to print same identity. And we get the same identity. Let's put a little exclamation mark. There we go. We got the same identity. And if they weren't equal to each other, so if they were different, then we wouldn't get this print statement. We'll go into print statements in a later section. So we've done that, and then we've shown that clearing the set doesn't change its memory location, and we were perfectly fine with that. So we'll just create our set again. So let's just do that. So we'll do the same. Let's create a set over here, and this time let's just have a look. So let's create a set, and we're going to print the identity of the set. So that's all fine. That will be in the usual way. We've got the memory location as well of it. Maybe we'll take a look at that, and we will clear our set now. So let's do the same thing that we did here. Let's clear the set. But this time we're not going to use s.clear. We'll try to do something else. So the first thing we'll try to do is s equals to, and we'll set it equal to an empty set. That should be very nice, shouldn't it? And after we've cleared our set in that particular way, we will print the set, and we can even stick it into memory and do all of our other stuff. So we'll put it into memory too. So we can literally repeat all of our code here. We can print the identity of the set, and we can even store its new memory location if we wanted to. Now we run this, and in fact I'll just run it, and we go over here and we get these two empty curly braces. And actually one of the things I should do is print here the type of S, because it looks like we've got a set back over here because we've got these two curly braces. So that looks like a set, but we notice we didn't get the set keyword. We got these two curly braces, so we think we've got a set. But when we run this again, it actually says class of dict. So we haven't got a set, we've got a dictionary. And if we were somewhere over here just in the beginning, print just for our sanity, we could print the type of the set just at the top. And we can see that we get class set over here. But using this empty brackets, we were expecting to get a set because we just populate it in the same way as all of these items. So it's just something that it turns in, we get this other class that we haven't come across yet, which is of type dictionary. Now we're going to do dictionaries next, but Python, what this is telling us is that Python uses curly braces for two different collection types. One is for the set, and the other one is for the other one is for the dictionary. And it's doing so. It will do some sort of type inference, but the curly braces is being the empty curly braces is being type inferred to a type of dictionary as opposed to or a set of dictionary as opposed to a class of dictionary as opposed to a class of set. So that's something just of point of interest, and we will get into looking at dictionaries in the later section. So we can't clear a set like this. Not only can we not clear a set like this, but so we printed the identity of it, but it's also a completely different memory. It's a completely different class. So let's continue from there, and we will try to clear the set again. So let's try to clear clear the set again. And we can introduce, or at least we know that we've got this class of set, so we can try to do this, which is s equals set. And I didn't show this in the previous section, but if I guess hover over it, we will see class set over here. Builds an unordered collection of unique elements. So it's a new empty set object. So in fact, I might just copy this little piece in here. This is actually what we're doing. Let's try to clear the set again with a new empty set object. And that will be a new empty set object. And this is the way, if you were going to construct a new set, and a new empty set, that because we can't use these curly braces, because we now see that the curly braces go into being a dictionary, that we need to set, if we wanted to create a set that's a blank empty set, that we would need to use this set keyword. Alternative, by the way, if we did want to populate it, we would put in, we would need to put in a list. So we couldn't just put in a whole bunch of, we couldn't just put this into the interpreter or into our line of code. This wouldn't work. It would throw us an error message, type error, expected at most 1 argument, but got 3. Well, here's the 3 arguments. It's expecting 1 argument, and one of the things that we would do or could do is put it into square brackets as in a list, and then it converts the list into a set. So over here it says build an unordered collection of unique elements, but it needed to get a list in order to do that. Or alternatively, funnily enough, we could have used a tuple as well. This would have also been sufficient. So either of these, this creates a set fine. So so long as we put in a list or a tuple, we could use this set method. But when we are creating a new set, if we've got items in it, we will use the curly brace method. If we are going to create an empty set, we kind of like need to do this, because we'll use the set method, because we can't use the curly braces. So anyway, we do that, and we print out S. So now we get our new set, which is quite comforting, because at least now we've got set in the same way that we had set here, where it belonged to the class of set. So we haven't got a dictionary, we've got a set, and we can actually do print the identity of it as well. Just let's do that over here. So we can print the identity of the set, and we can print, just for our comfort, just to show to ourselves the type of the set. So, and hopefully we get type set, and we get a class of set. But the one thing to note is, earlier on when we did this creating of a set and then s.clear, we had the same memory address, we had the same identity. Whereas when we do this set here, and then, well, this is definitely going to be, well, we didn't know it's going to be something different, but we've assigned it to, we've created a dictionary. That's gone into a different memory location. But even more so anyway, when we do s equals set, we don't get this new set over here. We actually get a different, sorry, we don't, we're not retaining the memory space. We're again moving our variable to a new part of the memory. So this way, and just to be for our little proof to ourselves, it's not the dictionary that's creating this change in memory. The change in memory is happening anyway. So when we do this s equals set to clear the memory, if we think we were going to do that, we're actually pointing to a new part in the memory. So s.clear is different from s equals set. So we can create, we can clear the memory space and have our variable still pointing to it, or we can create a new variable s and point it to a new memory space. So that is sets, that's a clear function, and that also highlights to a degree the memory space and how sets work, and effectively how a lot of the collections work. They retain their space in memory, they're immutable, but if we create a new variable, we will have literally assigned it to a completely new memory space. So that is sets and the clear method of sets in Python.